First question, the simple Bohr model cannot be directly applied to calculate the energy levels of an atom with man electrons. This is because, so the simple Bohr model cannot be directly applied to calculate the energy levels of an atom with many electrons because when we derive the formula for radius or energy levels, etc., we can make the assumption that the centripetal force is provided only by electrostatic force of attraction by the nucleus. Hence, this will only work for single electron atoms. In multi-electron atoms, there will be also repulsion due to other electrons, and the simple Bohr model cannot be directly applied to calculate the energy levels of an atom with many electrons. So correct answer for this question is option A, that is of the electrons not being subject to a central force. Option A. Looking towards the next question, that for the ground state, the electron in the hydrogen atom has an angular momentum equals to h, according to the angular momentum is h upon 2 pi. Okay, according to the simple Bohr model, the angular momentum is a vector and hence there will be infinitely many orbitals with the vector pointing in all possible directions. And actually this is not true because the Bohr model gives only the magnitude of the angular momentum. The angular momentum is a vector quantity, hence we cannot express angular momentum completely by the Bohr model. Hence it does not give correct values of the angular momentum of revolving electrons. So this is not true because the Bohr model gives incorrect values of angular momentum. So correct answer for this question is option A. Moving towards the next question, that taking the Bohr radius as A0 equals to 53 picometer, the radius of Li plus 2 ion in its ground state on the basis of Bohr model will be about. So we know the formula that radius is equals to A0 n square upon Z, where the atomic number of lithium is 3. Therefore, the radius of lithium plus 2 ion in its ground state on the basis of Bohr model will be about 1 by 3 times to that of the Bohr radius. Therefore, the radius of the lithium ion is near to R is equals to 53 upon 3, which is equals to 18 picometer. So, correct answer for this question is option C, that is 18 picometer. Moving towards the next question. A set of atoms in an excited state decays in general to any of the state with lower energy or into a lower state only when excited by an external electric field or altogether simultaneously into a lower state or to emit photons only when they collide. So a set of atoms in an excited state decays in general to any of the states with lower energy. So correct answer is option A. Moving towards the last question. The Bohr model for the spectra of a hydrogen atom will not be applicable to hydrogen in the molecular form, will not be applicable as it is for a helium atom, is valid only at room temperature, and both A and B. So Bohr proposed a model for hydrogen atom which is only applicable for some lighter atoms in which a single electron revolves around a stationary nucleus of positive charge called hydrogen-like atoms like hydrogen or helium plus 1 or lithium plus 2 or sodium plus 1, etc. It is not applicable to hydrogen in the molecular form, and also it will not be applicable as it is for a helium atom. So correct answer for this question is both A and B, because will not be applicable for the hydrogen in the molecular form and will not be applicable as it is for a helium atom. So correct answer for this question is option d.